Hello and welcome to the Practical Animal channel. The channel is for you if you want to know what it takes to work with animals. That could be with domestic species, companion animals such as dogs and cats, or it could be with farm animals. Or perhaps you want to work with wild animals, either in the wild as a field naturalist, or in captivity as a zookeeper, for instance. Every week I interview an animal industry professional asking about the skills needed to work with a particular animal. This week we continue with the 5th episode in the series of interviews with Professor Mark O Shea MBE. Mark is a Professor of Herpetology at the University of Wolverhampton in the UK. He is also a former presenter of several high-profile television natural history documentaries, predominantly on snakes. I interviewed Mark several days ago about what it takes to work with snakes. Today, he talks about what is involved in describing a new species of snake. And it's interesting to see the importance of museums in this process. You're not going to want to miss this one. Enjoy. What is the process that takes place, Mark, when a new species of snake is discovered?
Well, the process of describing a new species can be quite a prolonged one. First off, you have to have a specimen in your hands and you go, I think this is different. And that's applying, you can't tell molecularly whether it's different, but you can tell morphologically it's got a different scale count. There's some characteristic about it. And ideally, you should have more than one specimen. So you're sure it's not an aberrant characteristic. But if you're certain that it's a new species, you will need to preserve one specimen. Now, sometimes, I find new species both in nature, out in the wild, and in museums, in existing museums, where they have been catalogued not necessarily as what they really are. And I found new species in both situations. The main difference is I've never got malaria in a museum, whereas I've had it 6 times working in the field in 5 different countries. So it's a lot safer working on new species in a museum. But whether you're holding a newly captured snake in your hand in Papua New Guinea, or you're looking through a collection of snakes from Papua New Guinea in the Museum of Comparative Zoology at Harvard University, and you find one that you think, hang on, this is different from the rest. The process thereon is pretty much the same, except that you can get tissue samples from your new specimen, your one you've caught, and tissue samples that could be used for molecular techniques, where it is harder to get that from a museum specimen that's already been fixed and may have been fixed many years ago. But the process then is to document all the physical characteristics of the specimen and how they differ from similar species. And this is why ideally you'd like to have 2 or 3 or 4 specimens, so that you can actually see ranges in certain scale counts, the ventral scale count down the belly, and the subcaudal scale count and things like that, and whether there's any differences between males and females, sexual dimorphism, or if they're different colors, sexual dichromatism, or if there's a difference between juveniles and adults, an ontogenetic difference between juveniles and adults. So so it's a good idea to have a series, but you can describe, and we have, species from a single specimen. And what we have to be certain is that it is not an existing species because people used to do that quite a lot in the past when they didn't have the means of borrowing museum loans to your institution or going and visiting museums overseas easily or whatever and corresponding. We obviously have that all today, but in the 19th century, people didn't. And it'd be quite possible for two people in different places to describe the same species from different specimens because they didn't know the other person working on that material. But once you've determined that you're certain that it is new and you've looked at all the potentially related species, the other species that would be in its genus, and drawn up the characteristics that separate it, you have to write your paper, quite often with co-authors who've got their own strengths. Somebody might be a geneticist who's going to be able to look at the tissue samples. Somebody else will be doing the photography and preparing distribution maps and things like that. And it's quite a collaborative process. And it can go on for quite a few months, easily a year. I mean, people are generally holding down institutional jobs while they're doing this, or quite a few excellent amateur taxonomists describe new species as well, and they've got to hold down a job while they're doing this. So you work on this when you can, and it could take easily a year. And when you've written your paper and you bounce it backwards and forwards between your co-authors, which is a lot easier now with email than it was with penny post in the earlier in the late 19th century. When you're satisfied with your description, you send it off to a journal, and quite rightly, the journal then, it would be a peer-reviewed journal, which means that they will send your paper out to other experts, your peers, and they will read your paper and comment on it accordingly, and say, yeah, this is very good. We'd only make a few changes here or there, or have you seen this paper that's relevant? Or they might say, well, it's good, but it's not good enough to publish. You need to do more work in this direction. Or they may just say, this is bunkum. It's not a new species. Sling it in the trash. So any of those could happen. Well, assuming you get it accepted, it comes back and you've got minor alterations to make sure that the reviewers are happy, you send it back to the editor. It then gets into the line and eventually gets published. And if you think that let's assume we've got a widely distributed species, a snake for sake of argument, and it's found on the mainland, and it's found on one island off the coast. And you happen to have gone to that island and you've collected specimens there. Now, this species at the moment has one name, and the holotype, which is the name holding specimen, that was collected on the mainland, and the island population is assumed to be the same. So when you're on this island and you look at them in great detail, you think, hang on, no, this is different. This is different. All of these ones on this island have got this different scale count that doesn't match with the mainland. And I've looked at lots of the mainland ones. So you'd collect some specimens, which would mean having to sacrifice some for science. But you're proven right. It is a new species to which you apply a name. Now that species has got a name, if you consider it's only found on this island and they might be going to deforest the island or mine it for gold or something like that, that species now has a name. So you could try and get it protected through legislation. Without a name, it wouldn't have any legal standing and you couldn't protect it. So, and if it stayed under the big species that's also on the mainland, people say, well, that's only an island population, so what? It's all over the mainland. Yeah, but that island population turns out to be a new species. So to protect it, you have to preserve one or two or maybe three specimens so that you've got them in museums that other people can look at over the next 200 years and comment and compare with your paper and decide if you've got it right. But basically, until that animal has got a name, it can't have any legal protection. You could protect the island as a seabird reserve or something like that, protect the habitat, but protecting the individual species, it doesn't have any protection until it's got a name. And it's, I suppose, a bit like us. Unless you've got a tax number, a national insurance number, you've got a birth certificate that has your name on it, you really have no rights in law. So it's not that dissimilar for a species. So the odd thing is, to protect a potentially endangered new species, the first thing you have to do is sacrifice one or two of them. That might sound counterintuitive, but if you think about it, how can you protect it if you haven't described it? And people would say, oh, well, look, take a photograph. Photographs with rare species, protected species, a photograph is good for proving that an existing species occurs somewhere else. In New Guinea, for instance, there's a protected python in the mountains called Boland's python. Now, no biologist now working in New Guinea would think of preserving one because we know the species. And there are specimens in collections if we needed to look at and analyze all known Boland python specimens. But not so long ago, the species was found on a mountain chain at the end of the Papuan Peninsula, where it hadn't been recorded before. And the biologist who found it, working with locals, he didn't preserve the specimen, but he got a photograph. It's a very distinctive snake, and he's deposited the photograph as his proof that it's there, not the specimen. But that would not be sufficient proof in the case of describing a new species, because you can only look at the picture. Well, you could take off a dozen photographs, but really you do need to be able to examine the specimen. You need to count the scales underneath. If it was a lizard, one of the things you have to do is count the number of lamellae underneath the fourth toe, which is the longest running toe, and that sort of thing. It really doesn't lend itself to photography and lodging photographs for description. And people say, well, molecular techniques are great. You can do a lot with them. Yes, you can. They're very, very useful techniques, but they don't replace morphology. You still need to be able to describe that specimen. It's got 7 supralabial scales along its upper lips. It's got 9 infralabial scales along its lower lips. It's got its prefrontal and internasal scales fused. It's got a scale count around mid-body, one head length posterior of the head of 17, at mid-body of 17, but one head length anterior of the cloaca, it's got 15. These are characteristics, and you'd need, you won't get that from a tissue sample. So, tissue samples will not stand in for what's known as a voucher specimen. And if it's the new species name holder, then it is a holotype. And the other specimens that you might have collected at the same time to support your argument would be paratypes. And they're, if you like, holotypes in waiting. They're further adding to the information obtained from the holotype. But the holotype's the important one. And it's so important because, of course, with reptiles and amphibians, they're stored in highly inflammable 70% ethanol. It's so important that in museums, they tend to keep all their holotypes separate. And they often keep them in fireproof cupboards. In case a fire happens. And during the Second World War, the spirit collection in the Naturalist Museum in London, all the holotypes were removed. And it was a big job. And they took them all down to some mine workings in Surrey. Because if the museum got hit in the Blitz, they didn't want all the valuable type specimens going up. They didn't want the museum to go up, but it would have been too big a job to move all of their spirited specimens out of London. So what they did is they moved all the rest of the spirited specimens into the basement, but the really important holotypes that were irreplaceable went to this mine working in Surrey, and they all started coming back around about 1946, and they came back and then were reaccessioned into the museum. So when you're looking through specimens, if you've got one that starts with it has a prefix 1946 dot, then you know that was a type specimen that was taken out of the museum during the war. Other museums weren't as fortunate. In between 13th and 15th of February 1945, the Allies bombed Dresden. Everybody knows about the terrible bombing of Dresden, and the way that the fires were so fierce that people were sucked off the streets into them. Well, another casualty of the fire was a natural history museum. And with a lot of ethanol specimens in ethanol, it'll have gone up like a Roman candle. And all the type material, everything that was there at that time's gone. And I'm working and I'm looking and I find an old paper from before the Second World War that cites a specimen collected in 1888. And it's an important specimen. I need to see it. It's in Dresden. It's got the museum configuration MTKD. And I think, no, that's gone. No point in that's gone. That went. And so there are big gaps. And this goes for all organisms. When I was working in Papua New Guinea in the 1990s, there was a team of botanists from the Canberra Botanic Gardens, and they were going to, they were trying to recreate the orchid collection by a German called Schlechter. And he'd collected all these orchids all over German New Guinea. And they were all in one of the museums that went, or herbariums that was destroyed in the war. And so what the Canberra Botanic Gardens was doing was they were going back to the type localities, the places where Schlechter had documented he'd got that orchid, and they were going back there and looking for one in that area. Well, they're fortunate because plants don't generally move around. John Wyndham's triffids did, but you know, that's not quite the same thing. But animals do. And it's quite hard to go back to an animal's type locality and expect to see one sitting there waiting for you on a log. It doesn't happen. But sometimes that is necessary. It's just harder for zoologists than it is for botanists. And lots of museums have had fires. The Zoological Museum in Sao Paulo, no, it's the Butantan Institute in Sao Paulo, that burned down in 2010, loss of all their wonderful collection. The Zoological Museum in Rio de Janeiro, the Natural History Museum in Budapest in Hungary, the Natural History Museum in Lisbon, Portugal. They've all had big fires that have destroyed a lot of specimens. And this is obviously a major fear. And like Berlin, if you go to the collection in Berlin now, you have to wear on your shoes, if you go into the spirit rooms, you have to wear static electricity dischargers so you don't create a spark as you're walking around, which might end the collection. This is and like I visited the Smithsonian Institution, which, as you probably know, is in Washington, D.C. And it's got one of the best collections in the United States. But the idea of having all this highly flammable alcohol sitting up on Capitol Hill didn't appeal. So although you can go to the Smithsonian and you can see their dinosaurs and their mammal displays, things like that, if you want to look at the reptiles and amphibians in their off-show collections, I'm talking about the off-show collections, not the stuff the public sees, of course, you have to go out to Maryland, to a place called Sweetland, to an industrial estate, and that's where it is. It's not. And the Natural History Museum in London may yet be moving a lot of their material. That's because they're running out of space, but they may be moving a lot out of London. Not the public displays, of course. When a visitor goes to the museum and they walk around the cabinets and they see all these wonderful exhibits, many of them, certainly quite a few of them haven't changed in decades. But that is a fraction of what the museum holds in its off-show areas for researchers. And I liken it to walking past the windows of Harrods and looking in and seeing what they've got on display. Well, not much compared to their total stock inside the store and inside their warehouse at the back of the store. If you think about it like that, you can see that the exhibits that the public sees are a shop window, nothing more. And they're there to educate. The real research specimens are off show and only available to researchers, obviously.
The interview with Mark O Shea continues next week, when he answers the question of what happens after a new species of snake has been described. For instance, is the next step a survey to find out if the new species of snake is critically endangered or not. You won't want to miss that one. Here we are, back in the Practical Animal Channel Wildlife Garden in late winter. If you liked this video with Mark O'Shea and found it useful in explaining what is involved in describing a new kind of snake, then please consider clicking like. If you want to work with animals and wish to have access to more exclusive content about how to do so, then please think about subscribing to the channel and sharing it with anyone you know who likes animals. Thank you very much indeed for taking the time to watch this video, and we end with our resident male pied wagtail chasing a female around the food bowl. Maybe she is feeling hungry, or fruity, or both. But then the blackbird arrives to put a damper on things. See you next weekend.